We've made it. Last day, last lecture, whatever you want to call it. Last practice final exam. And I'm sure you guys will appreciate if I just go through it. So let's do that. Problem 5. Let f of x equal e to the x cubed minus 5x squared plus 3x plus 4. Question is, what are the critical numbers? This one's extremely straightforward. There's only one thing that we're gonna do. We're going to, you guys can all say this with me, take a derivative, set it equal to 0, solve for x. So let's do just that. What sort of rule are we going to be using? It's not too difficult. We're going to use the chain rule. Think of e to something as e to the parentheses of that thing. And then there's your parentheses for inside and outside. All right. F prime is going to be derivative of the outside. Derivative of e is still e. Leave the inside the same. Minus. Multiply by the derivative of the inside. Of course, the derivative of the inside here is exactly the exponent. So this is going to be 3x squared minus 10x plus 3. I'm going to specify these. This is derivative of the outside, leave the inside the same. And multiply by the derivative of the inside. Okay, but if we're going to set this equal to 0 and solve for x, let's do that. So I'm going to rewrite it as 3x squared minus 10x plus 3 e to the x cubed minus 5x squared plus 3x plus 4 equals 0. How do we actually do this? Well, anytime, this is kind of a good rule of thumb, any time you have two expressions multiplied together equal to 0, and you're solving for the variable, of course. These two expressions, you can, since you're multiplying them, if either expression is equal to 0, then the whole thing is equal to 0. So you can split the problem at the multiplication, basically, is what I'm saying. So what's that? You know, what am I saying? I'm saying in this case, our problem becomes we want to solve this first term. This in blue. So our problem becomes this piece, 3x squared minus 10x plus 3 equals 0, and the second term, so this one here, e to the x cubed minus 5x squared plus 3x plus 4 equals 0. So all I've done is I've split the problem at multiplication. That's what I'm saying. So solve both for x. Okay. So let's just start. With this one, e to the x cubed minus 5x squared plus 3x plus 4 equals 0. We can take a natural log of both sides. That's natural what you would do. Natural log of 0. But actually the natural log of 0 is negative infinity. So you're looking for a spot where x cubed minus 5x squared, my fault up here. Not that you need to know that, but I'll explain why this is somewhat important. So the fact that this is equals negative infinity, that means there are no solutions. There are no solutions to this part. Another good excuse is that e to something is always positive. So never 0 really is what I'm saying. However you want to think about that is fine with me. But either way, there are no solutions to this part. So, but that was just the first of these two parts, right? The other one is solving this polynomial equation. Call this part 1. So then part 2 is solving the polynomial equation, 3x squared minus 10x plus 3 equals 0. And as always, if factoring looks tough, use the quadratic formula. Which we'll do here. So x equals negative b plus or minus the square root of b squared minus 4ac, 4 times 3 times 3, all over 2a, 2 times 3. So this is 10 plus or minus the square root of 100 minus 36, sorry. I do make sure that the numbers always work out, over 6. 10 plus or minus the square root of 64, all over 6. This is 10 plus or minus 8 divided by 6, and so we end up with 18 over 6, and I guess minus would be 2 over 6, which is exactly what the problem gives us, x equals 3, and x equals 1/3. There you go. Pretty straightforward problem. You just kind of have to recognize that the e term is always positive. You could have thought about dividing both sides by that term since it's positive, and then solving for x equals 0, and so on. So there's lots of ways of thinking about basically getting rid of that exponential term after you've taken a derivative. It's kind of the special case that I wanted to bring up in this problem. Okay, problem 6. Says let f of x equal 2x e to the minus x squared and g of x equal 0. Question: what is the total area bounded between the curves? And I give you a hint here. Hint: the only intersection point is at x equals 0. So you will be integrating from minus infinity to plus infinity. And you guys are probably freaking out right now and saying, what does this mean? Well, all it means is an integral of a function from minus infinity to plus infinity. This is equal to, well, it's still the antiderivative, minus infinity and plus infinity. But how do you define those? This is the limit as x goes to infinity of the antiderivative minus the limit as x goes to minus infinity of the antiderivative. So you treat it the exact same way you would treat other things, a regular integral. You just take limits at the end. So I wanted to introduce that concept here. What better time to do it than studying for the final, right? So let's just do that. As always, we want to determine total area here is now going to be equal to minus infinity to plus infinity, top curve minus bottom curve. Dx. So just as before, we just want to determine which curve, f of x or g of x, is on top versus bottom and where. Let's graph. And of course, you can use Wolfram Alpha or your calculator to graph this if you want. So what does it look like? Of course, g of x is not a tricky one here. G of x is equal to 0. F of x is just a tiny little bit trickier. It's got this sort of a shape. And so this is our total area, piece in green. I mentioned in the hint the only intersection point is at 0. So there's our 0, 0 intersection point. We see that f of x is on top to the right and on bottom to the left. So we have two choices. We can do this by symmetry or just by integrating everything directly. I'm just going to mention that here. By symmetry, the area in green is equal to twice the area on the right. You're going to see me use that later, but so we can do this two ways. So total area, TA, in this case is going to be minus infinity to infinity, top curve minus bottom curve, dx. But it splits at 0, so we're going to split at 0, minus infinity to 0. What is the top curve there is 0, and the bottom curve there is f, which is 2x e to the negative x squared dx, plus 0 to infinity, and then the curves just switch place. Minus 0 dx. And if you've already forgotten g of x, I did it in red, yeah, f of x. And then what I was saying earlier, the part that I like is by symmetry. This is 2, 0 to infinity, just the part on the right. So the part on the right is the second term, 2x e to the minus x squared dx. So we want to actually calculate this. So we'll calculate an antiderivative of 2x e to the minus x squared dx. And how many choices do we have? We have either integration by parts or we have u sub. Choice 1, I say u sub is more common, usually. Choice 2, integration by parts. And we use this if you think you can find both a function and its derivative. I always like to say that. You find both a function and its derivative. So can we do that here? I would hope most people will say that we can find a function and its derivative here. Should be able to find both a function and its derivative in our integral. Otherwise, follow the u sub priorities, and it gives it to you. So what are our priorities? Priority 1, natural log, if it exists. which it doesn't. Priority 2 is denominator, if it exists, which it doesn't. And priority 3, we get to the exponent of e, if it exists. And indeed it does. So we'll use this, priority 3. So then we let u equal negative x squared, which gives du equal negative 2x dx, which we almost have in our integral, right? Just compare this. So there is almost du, and there's definitely u since we chose it to be this. So this is definitely u. This is almost du. What do we have to do? We just have to bring that minus sign over to the other side. So we're going to call this negative, not negative 2, negative du equals 2x dx. So then when I write this out as 2x e to the minus x squared dx, I can identify all my pieces that I want. There. And my other piece here. Where does that put me? That puts me at integral e to the u negative du, also known as negative integral e to the u du, equals negative e to the u plus c equals negative e to the negative x squared plus c. So this is the antiderivative. Means when I want to evaluate this, I'm really doing this. 2 negative e to the negative x squared plus c at 0 and infinity. And what's going on here, that's really negative 2e, well, there's limits, right? Limit as x goes to infinity of negative 2e to the negative x squared plus c minus, and then we evaluate everything at 0. A lot easier to evaluate at 0, negative 2e to the negative 0 squared plus c. You have a few choices here. Calculator or graph, right? I showed you the graph. The graph looked like that. Didn't draw that very well. That. So equals 0 as x goes to infinity. However you want to think about that. The piece on the left becomes just c. And then the negative sign distributes. We get plus 2. E to the 0 is just 1. 2 times 1 minus c. And so we get an answer of 2, which is the answer the exam gives. This is a slightly new concept. It's not out of this world, you know. I would assume that you can utilize your resources around you to figure out what it means to basically plug infinity into our function instead. It's just a limit. And yeah, we're going to have more practice with it right now. I won't do these on the final. I just wanted to introduce them here. I won't do... they're nice to introduce. They get used a lot in actual mathematics and stats and all sorts of other disciplines of science, so it's pretty important to introduce them. So problem 7. It's pretty easy, straightforward anyway. 2x, integral of 2x e to the negative x dx from 0 to infinity. So we have that infinity limit again. But of course if we're going to solve this, we need to find an antiderivative again. Really, I would just say you need to find this without the bounds first. 2x e to the minus x dx. And just as before, we have two choices. 1, u sub. 2, integration by parts. Some of you might be wondering what the difference is here. Hopefully, when I point this out, you'll notice. There you go. E to the minus x in this problem. E to the minus x squared in this problem. So there's a very subtle difference here where it's e to the minus x versus e to the minus x squared. That's going to make a huge difference because since it's not e to the minus x squared, we don't have both a function and its derivative. What I'm saying by this is, like, if u equals negative x, then du equals negative dx, and we've gone nowhere. By u sub, so that's not going to work. There's really, if you follow the priorities of u sub, you're going to get nowhere because it's going to tell you to make u equal negative x, and then du goes to negative dx, and it doesn't simplify your problem at all. So we're going to have to do integration by parts. Integration by parts also has priorities. Right, the first priority here is, this is for what u would be. U equals, maybe I'll rewrite that a bit. First priority here, u equals, first is the natural log of x, if it exists. Does not, and then the second choice is a polynomial. So this is like powers of x, if it exists. And it does. So then we let we're going to let u equal x and dv equals what I like to say, everything else, which is going to be e to the minus x dx. And okay, I didn't worry about the 2. Hopefully you guys have figured out why. Don't worry about the 2. It can pull out front. So that's why I'm not worrying about the 2, but if that's u and that's dv, then we can find du is just going to be dx, and v is always the integral of dv, which is the integral of e to the minus x dx, and general exponential rule, or another version of u sub, or however you want to think about this. This gives you negative e to the negative x for v. So circle those. So then this integral, x e to the minus x dx equals 2, and then we get uv minus integral v du, which is going to be uv, so u is x and v is negative e to the negative x, right? I'm going to circle those here. V is negative e to the negative x, u is x. I'll just pull those down maybe. U is x. V is negative e to the negative x. Minus integral v, same v comes here. So negative e to the negative x will make that positive. Du is dx. Make that explicit here. Oops. Wanted the crayon. So there you go. There's your uv minus v du. And things start to work out because this is negative x e to the negative x. Once again, by the same virtue as we saw before, this is just the general power rule for e, or however you want to think about it, minus e to the minus x. So I rewrite that as, I'll rewrite it as negative 2 x plus 1 e to the minus x. You can rewrite it in whatever form you want. Yeah, that's not a huge deal. It just looks kind of pretty the way that I wrote it. So we'll leave it like that. Okay, so then this integral here, this is your antiderivative. So then this integral from 0 to infinity, 2x e to the minus x dx equals the antiderivative evaluated at the bounds. And so this is just like before, the limit as x goes to positive infinity of negative 2 x plus 1 e to the minus x minus doing everything at 0 is just negative 2, 0 plus 1 e to the negative 0. Again, by calculator or graph, you'll find out that this equals 0. And so this is going to end up being 0 minus 2. So 0 plus 2 times 1 times 1. So this is, again, going to be 2. So this is actually, you'll notice that the big difference here was that we've technically only integrated half as much, but the power of e is changed in this case. So you actually get like twice as much area when that power of e is 1 time smaller. That's one way of thinking about it. But anyway, this is the answer the exam gives. I just kind of liked it that I could do 2 problems so similar with e in them that looked so similar, and by changing one part of it, you can do integration by parts versus u sub. Kind of like that between the last 2 problems. Okay, so problem 8, and then we're done for the semester. Well, you guys are kind of done. You have to take a test, which I'm sure is going to be so enjoyable, and I get to grade it. But we're done with these, I guess, for the end of the semester. So this problem says, the rate at which your new pet raccoon poops is based on how much you feed it, such that the relationship between the two is p prime of f equals 3f minus 21 over the square root of 10 square root of f. I have no idea if even raccoons are allowed to be pets. I would assume so. Probably only city restrictions that would say why not, but maybe pretend you're a zookeeper or something. So where P is the amount of poop in grams and F is the amount of feed in grams, how much has it pooped if you start feeding it with 0 grams of feed and now have fed it with 10 grams of feed? So this is a rate at which it poops. So think derivative, which is why I gave you the prime in the expression there. And then we want to know this is the question here. How much total poop there is if we started at 0 grams and ended at 10 grams. So P by itself, how can we extract P from P prime? P of F from P prime of F. I think everybody can agree if I have P prime and I want to go to P, this is an antiderivative. The integral of P prime of F dF equals P of F plus C, but who really cares about the plus C, because we're going to be looking at the difference between F equals 0 and F equals 1, or F equals 10, so really we want, since we care about the difference from giving it 0 grams to giving it 10 grams, we find instead the integral from 0 to 10 P prime F dF, which is of course going to just be P of 10 minus P of 0. So let's do this to find this integral. We have 3f minus 21 over square root of 10 square root of f df. And as always, it's much easier to think about square roots as 1/2 powers. Make sure this one shows up a little better. And then we just use power rule. This is going to be 3f squared over 2 minus 21 over 10 1/2 f to the 3 halves divided by 3 halves. Evaluated at 0 and 10. Plug 10 in. 3 times 100 over 2 minus 21 over 10 to the 1/2, 10 to the 3 halves over 3 halves This is me evaluating 10. Then I'm going to subtract evaluating 0. 3 times 0 squared over 2 minus 21 over 10 to the 1/2. 0 to 3/2. Thankfully, 0 to any power is 0 over 3/2. This whole piece is 0 here. So we only have the first part, and that first piece simplifies to 150 minus, let's see what this piece simplifies to. We might have to use, you use your calculator, of course, you cheaters, but of course it's not cheating on this exam because open calculator. But let's do this with exponential rules. So the first thing I'm going to do is bring the 3/2 from the bottom up to the top as 2/3 times 21 times 10 squared times 10 to the 1/2. That's an exponential rule right there. I'm dividing, or sorry, 10 to the first power times 10 to the 1/2. That is actually 10 to the 3/2, and then I have this 10 to the 1/2 on the bottom. So I'm just going to mark that these are the same by exponent rules. And then these 10s cancel, or those 10 to the 1/2 cancel, and so we get 150 minus, I guess 1/3 of 21 is 7, so 2 times 7 times 10 is 150 minus 140 is 10 grams of poop. So if we feed it 10 grams of food, we got 10 grams of poop. I don't know if it absorbed nothing or what. It's a raccoon. Maybe it's eating other things that we don't know about. But anyway, this is the answer the exam gives. And we're good to go. So that's all. That's the semester for you. Aside from your final exam next week, I'll make an announcement, like I said, on Sunday night with everything you need to know for that. The exam is open from Monday through Thursday. So Monday as early as it can be, basically the midnight of Sunday night, but it's technically Monday morning, and then through the midnight of Thursday night, which is technically Friday morning, it will be open. And then, yeah, thank you all for a good semester. I know it's been crazy with the coronavirus and everything, but I really liked you guys, had a good time, and I hope to see you around campus periodically. I'll say hi, and hopefully you'll say hi back. All right, bye.